Okay, good day everyone. So today we're gonna work with proportionality theorem. Okay, proportionality theorem, it's a very important theorem in grade 12. So it's a part and parcel of the Euclidean geometry that you'll work with this year. So please, before attempting this topic, make sure that you have done your due diligence on the grade 11's Euclidean geometry. It is extremely important because we require those skills here in proportionality theorem and similarity theorem. So but today only we're going to focus on proportionality theorem. So we're going to work with ratios and proportions and how to prove the proportionality theorem and some exam based questions. So now let's dig into it. Okay, I hope you are happy and excited to be here as I am excited to present this lesson to you. So now ratios and proportions. So now the definition, the formal definition of a ratio, we call it what is a comparison of two quantities. That is, the ratio of A to B can be expressed as. So for example, let's say you had, let me fix my pen. Let's say you had A is to B. This reads as A is to B. So this is logically equivalent to A over B there. Okay, so A is to B is the same as saying A over B. So we call that a ratio. But what happens when we now deal with proportion? All right, when we deal with proportion, what happens? When we work with proportion, we say proportion is an equality of two ratios. That means you have to have maybe ratio 1. Let's say our ratio 1 is 1 over 2. And let's say ratio 2, maybe it's 6 over 12. We can all agree that 1 over 2, it is equivalent to 6 over 12, because 6 goes how many times into 12? Twice, and 6 goes how many times into 6? Once. So it's 1 over 2. So these two things are in the same proportions. What I want to say is that ratio 1, it's 1 over 2. Ratio 2, it's 6 over 12. So meaning that these two are equal. These two ratios are equal. Hence, we call them proportion, meaning they're in the same proportion. But when we had 1 over 2, we will call it a ratio. 6 over 12 is just a ratio. But if we decide to equate them, we call them what? A proportion. Okay? So now let's move on to important example 1. So important example 1, but they say consider the following. 1 over 2 equivalent to 4 over 8. We can both agree that 4 goes how many times to 4? Once, into 8 twice. So we want to write the above as different proportions. So meaning we want to write this in different forms that we can come up with. Okay, now let us check. So number one, we have 1 over 2 equivalent to 4 over 8. So this can be written as what? This can be written as 2 over 1 equivalent to 8 over what? 8 over 4. Because 2 over 1, it is equivalent to 8 over 4, because 8 divided by 4, it's how much? It's 2. Then our reason there will be like, we just flipped what? We just flipped the ratios. We just flipped the ratios. We took the denominator to the numerator in place of numerator. Then we took the numerator in place of what? The denominator there. So now another way to do it, number 2, we had 1 over 2 equivalent to 4 over 8. This can be written as what? This can be written as maybe 8 over 2 equivalent to 4 over 1. Why is that? Because 8 over 2, it is equivalent to 4. So we just swapped we just swapped 8 and 1 there. We just swapped 8 and 1 there. Now let us check another one. Let's say we still have 1 over 2, 4 over 8. So this can be written as 8 times 1 equivalent to 4 times 2. Yes, it makes sense if you cross multiply. If you say 8 times 1, you get 4 times 2 because they're both equals to how much? 12. So our reason there will be just cross multiply. We just cross multiplied them. So now let's say you had what? Again 1 over 2 equivalent to 4 over 8. This can be written as what? We can just say 1 equivalent to 4 times 2 divided by 8. So now from number 3, we just divide both sides by 8. So 8 divided by 8 is 1. So 4 times 2 divided by 8 is that. So this can be written as that. So our reason there will be cross multiplication, cross multiply, and divide by what? Divide by 8 there. So that's how you can write 1 over 2 equivalent to 4 over 8 as different proportions. Remember we said proportion is an equality of two ratios. So we had ratio 1, 1 over 2, ratio 2, 4 over 8. So now we want to write this proportion into different proportions. So for us to write this in different proportions, we can somehow do that. Okay, I hope you are happy with important example 1. So that's how you can solve important example 1. So your homework, please do the above question for general case. Maybe set 1 over 2 as AB over CD and 4 over 8 as EF over GH. Then do the above. So that's your homework there. So please make sure that you do it. Remember, understanding comes from doing. So if you don't do it, you won't understand it. So let us move to another example. Important example 2. Alright. So important example 2, they say if P divides line segment AB in the ratio of 5:4, determine the ratios of the following. Okay. AP is to AB, AB is to AP, and what? And BP is to AB. Now we will start with our line segment. So this is our line segment. Our line segment, we have what? AB. We know that P divides what? P divides line AB or line segment AB there. So now it is clear that we will have 5. Let's say we will have what? We will have 5K here. I will explain now why we put K. We have what? We have 4K here. Why? Because it is clear from this line that PB it's longer and AB it's shorter. So it will make sense for me to give PB 5K and what? And AP 4K there. Now check something. So if we say 5:4, we see that this is equivalent to 5K is to 4K. But remember we said that this can be written as what? As 5K over what? Over 4K there. So this is equivalent to 5 over 4, which is equivalent to 5:4. So those K's, they represent that this is just a ratio. Alright? This is just a ratio. K can be any number that is positive. Alright? it can be 2. So that means 5 times 2 is how much? Is 10. That means that 10, it is the length of PB. So that's how you can maybe work with ratios then. So you always need to put sort of an unknown variable to actually show that this is a ratio then. So that please note this down. This is very important. This is very important. So now let us solve number 1. So please, it is always a good practice to pause a video and try this question on your own, and maybe when you are done, play back the video, then see where you went wrong. So number 1, we have AP is to AB there. AP is to AB. We have defined AP is to AB as what? As AP over AB. We have learned that from the definition of what? Of ratio, that A is to B can be written as A over B. So they are logically equivalent. So now AP is to AB, it is equivalent to AP over AB then. So now let us find AP from our sketch. We see that AP is how much? It's 4K. What about AB? What about AB there? Now we see that our AB, let me just choose another color there. Maybe, yeah, maybe this one. We see that AP, it's 4K. What about AB? AB is just 4K plus 5K. So now we will say we have what? We have AP as 4K. What about AB? AB, it should be 4K plus 5K, which is 9K. So now we have 4 over 9. Alright? We have 4 over 9, which is equivalent to 4 is to 9 there, which is 4 is to 9 there. Okay, so that's how you can solve AP over AB using this sketch. So I hope it's clear to everyone that this is how we solve number 1. So let us check number 2. You have your AB is to AP. AB is to AP. So what is AB? So we can write this as AB over AP. So what is AB? AB, it's clear that it's 4 plus 5K, which is 9K. So what about AP? AP is just 4K. So now our answer is 9 over 4, because K divided by K is 1. So now your answer will be 9 is to 4. Your answer will be 9 is to 4 then. Okay, so now let us check number 3 then. Number 3, you'll have PB is to AB. PB is to AB. So now what is PB? We check that PB is just 5K, but you will do it after we have written this in different form. So it's PB, sorry about that, it's PB over AB. So what is PB? PB, it's 5K. What is AB? AB, it's 9K, because it's just 4K plus 5K, which is 9K then. So now we will have 5 over 9, which is equivalent to what? Which is equivalent to 5 is to 9 there, which is equivalent to 5 is to 9 there. So now this is how you do number 1 up to 3. So now what about number 4? I'm just gonna do number 4 here. So what about number 4? So suppose that PB is 10 centimeters. Okay, suppose that PB is 10 centimeters. Now you want to find AB and use it to find the length of AP. Okay, we want to find what? We want to find AB and use it to find the length of AP. Remember, these two, 4K and 5K, are not the lengths. They are just ratios. Okay, that is why we have inserted the unknown letter K to show that this is just the ratio, not the length. So now we will just set PB over AB to be equivalent to what? So what is PB? It's just 4. What is AB? AB, we know it's 9. Okay, so AB is 9. So now it is clear that PB, it is given as how much? As 10, but AB, it's unknown, but our length is our ratio, it's 4, and that one is 9. So we have 10 over AB, which is equivalent to 4 over 9. This is true if and only if we cross multiply. You'll have what? You'll have 4 AB equivalent to 10 times what? 10 times 9. Remember, we have worked with writing proportions, one proportion in different proportions. So this is how we do it. So we're going to use this form, number 4, to find what? To find AB there. So now what is our AB? AB will be 10 times 9, which is 90. 90 divided by 4, which is just 22,5. This is just 22,5 centimeters there. So that's our AB there. That's how we find AB there. But now we need to use AB to actually find the length of what? Of AP. So to do that, we will say AB divided by AP, it is equivalent to how much? Let us see. AB, it's 9. What about AP? It's 4. Okay, so this is true if and only if. What is AB? What is AB? We know AB is 22,5. What is AP? AP unknown. We are looking for AP, which is equivalent to 9 over 4. Now we need to cross multiply. So therefore, our AP, if you cross multiply and divide, so it will be just 22,5 times 5 divided by 4. So your divided by 9. Sorry. Yes, it's 22. Sorry, you'll say 22,5 times 4, and you say 9 times AP. So 22,5 times 4 divided by let me just do it, because by inspection it will be wrong. So let's say you'll have sorry about that, you'll have 22,5 times 4 equivalent to 9 AP. So dividing both sides by 9, so it's 22,5 times 4 divided by 9, which is equivalent to 10, which is equivalent to how much? Which is equivalent to 10 centimeters there. So the length AP is equivalent to 10 centimeters there. So I hope this is clear to everyone. This is how we solve what? This is how we solve This is how we solve important example 2 there. So please make sure you write this example in your own handwriting, and if you have tried this question, review your answers, review how to do this question there. So let us go to important example 2 there. Okay, this one is tricky, but yeah, it's doable. So important example 2, they say a line segment with the ratio of P is to Q, it is equivalent to 3 is to 2. Determine or find the value of Q plus 2P is to P plus 3Q, where P and Q are element of all real numbers. Okay, where P and Q are element of all real numbers. So now let us try to solve this one. So the way I'm gonna solve it, I'm gonna say, start with my solution. I'm gonna say, let P is to Q to be equivalent to 3 is to 2. We know by definition of ratio that or proportion that P over Q, it is equivalent to 3 over 2. This is just definition of what? Definition of proportion. Alright, we know that by definition we have this. Okay, now we will set Q plus 2P is to what? Is to P plus 3Q to be equivalent to Q plus 2P divided by P plus 3Q. So this is just again the definition of what? Of proportion there. This is just our definition of proportion there. Now we will somehow write this in a different form. We will say, check. We will say we will divide this guy, the numerator and the denominator, by what? By Q. Meaning I'm gonna say Q divided by Q plus 2 into P divided by Q over what? P divided by Q plus 3 into Q divided by Q. Alright, so this is equivalent to 1 plus 2 into P over Q over P over Q plus 3 then. So our reason, we have just divided by what? Divide by Q, the numerator and the denominator then. But now we know something about P over Q. We know something about P over Q. P over Q, it is equivalent to 3 over 2. So that this implies that we have something like this. We have something like this. Sorry. We have something like this. Something of this form. 1 plus 2. What is P over Q? 3 over 2 there. Now what is P over Q? We know that P over Q is 3 over 2 also plus 3. So we can see that 1 plus 2 over that, so it's gonna be let us confirm with our calculator. We see that 1 plus 2 into 3 over 2, we have 4. Then your numerator will be 3 over 2 plus 3, it is just 9 over 2. So this is equivalent to how much? This is equivalent to 8, sorry. This is equivalent to 8 over 9 there. 8 over 9. This is equivalent to 8 over 9. So when you conclude, you're gonna say, therefore, the value of what? The value of Q plus 2P is to P plus 3Q. It is equivalent to 8 is to 9 there. So this is how you solve important example 2. So let us recap. We said let P is to Q to be equivalent to 3 is to 2. But we know by definition of proportion that P over Q it is equivalent to 3 over 2. Now we go to this guy. We say Q plus 2P is to P plus 3Q. It is equivalent to Q plus 2P over P plus 3Q. So now we have to be smart about it. We divide both numerator and denominator by Q so that we have P over Q there. So now Q over Q is 1, then P over Q like that. So it's 1 over 2 into P plus Q, P over Q over P over Q plus 3. So now we know that P over Q is 3 over 2. So now if you substitute, you will have something like that. So now the value of Q plus 2P is to P plus 3Q. It is equivalent to 8 is to 9 there. It is equivalent to 8 is to 9 there. And I think we need to put a little of a restriction there. Let us put our restriction where P and Q are element of all real numbers which are non-zero. There. So I hope this is clear. All right. So now let us go to 1.2. Now let us go to 1.2. When we get to 1.2, we are working with the area of what? The area of basic triangle and a helper definition. I'll explain further what we call a helper definition. So now I can somehow construct the line from A to what? To maybe a point here. Okay, so I see that this is a perpendicular line. So now we have our base from B to D. There we have our base. This is a base, and also from D to E we also have a base there. Okay, so both triangles share the same base and height, if you can check. So now the line A to what? Let me call this C. Okay, so AC is our perpendicular line and it is shared by both triangle ABD and ADE. So they share the same what? The same base and height there. So now going to our helper definition. This is a very important definition. So they say triangle ADC and BCD lie between parallel lines. So let's say this line it's parallel to this line. Okay, AB is parallel to CD. We say area of triangle ADC. So let us check. Where is ADC? ADC. Area of triangle ADC, it is equals to the area of triangle BCD. What could be the reason for this? What could be the reason? The reason is that they lie between parallel lines and they share the same base and the perpendicular height. So we have height h here. Let's call this h, sorry about that. We have height what? Height h, and this is h. And as you can see that these two triangles, they share the same base. Let's call this our base there. So they share the same base. So the definition is very powerful. It says that if you have two triangles that lies between parallel lines and they share same perpendicular height and the same base, that means the area of those two triangles are equivalent. So like this, we see that triangle ADC and triangle BCD, they lie between two parallel lines and they share the same perpendicular height, meaning that they have the same base. So that means their areas are equivalent. So this is our helper definition. This definition is very important. It will help us when we prove proportionality theorem. So yes, as I've said, the above definition leads us to a theorem, okay, which is theorem 1. We call this theorem proportionality theorem. Okay, so it says a line parallel to one side of a triangle cuts the other two sides so as to divide in the same proportion. What do we mean by that? Please pause a video and think about this definition for a second. So I hope you have paused the video and thought about this definition. So we say the line parallel to one side of a triangle cuts the other two sides so as to divide in the same proportion. So it is clear that BC, as it is given, that BC, it's parallel to DE there. BC, it's parallel to DE. So we say that if these two lines are parallel, then AB over BD, it is equivalent to AC over CE. That's our definition. That's what we have encountered previously. So now, if BC is parallel to DE, then we have a right to say that AB over BD, it is equal to how much? AC over CE there. Alright? So now, but of course, we can appreciate this theorem as is, but we gotta do what? We gotta show the proof, the concrete evidence that this actually holds. Okay? How can we prove that? Please make sure that you understand how to prove this theorem, because it is examinable. It's about 5 marks in your exam, so please make sure that you know how to prove it. So number one, we will start by doing what? By constructing height K and H. So let us say we have your 90 degrees here, and this is your height K. Then you have your 90 degrees there. Then this is your height what? Your height H. So now this height H goes from here to there, goes from there to there. So now we want to prove that AB over BD, it is equivalent to AC over CE. Let us continue. So I'm gonna start by finding, my proof will start like this. I'll say area of triangle ABC. I'll start by finding what? Area of triangle ABC there. So let us check, where is our triangle ABC? ABC. So we have our perpendicular height K there. So the formula to find height is just half base times what? Times height. We see that our base is this one. So this is our base, and that's our height K there. So now to find this area, we will just say half times what? Base, which is AB, times what? Times K, which is our perpendicular height there. Right. So now let us proceed. Let us find the area of triangle BCD. So with triangle BCD, triangle, let us highlight triangle BCD, triangle BCBCD. So we want to find area of triangle BCD. So I think you remember by helper definition we have stated that this, you can see that we have two triangles, they share the same base and same perpendicular height. Okay, so check this one. This triangle, it shares what? The perpendicular height with triangle ABC. Okay, so now we will just say sorry, half times what? Times BD, which is our what? Our base there. Our base. This one. This is your base. Okay? This is your base. So what is height? What is your height for this one? Your height is what? It's K there. Because this is your base and your height is this one. Your height is that one. K there. So we have K there. Okay? So let us name this 1 and let's name this what? 2 there. So I'm gonna say from 1 and 2. From 1 and 2 we have that area of triangle ABC over area of triangle what? BCD. This is equivalent to how much? This is equivalent to 1 over 2 times what? AB times K divided by 1 over 2 times BD times K. So as this is clear, we see that this and that this and that, they go away. So I'll have what? I'll just have AB over BD there. I'll just have what? AB over BD there. So the reason we are doing this is just definition of what? Of ratio. We have spoke about the definition of ratio, that when you have ratio 1 and ratio 2, you can somehow when you have ratio 1 and ratio 2, or not ratio, let us go back to confirm. Yeah, when you have A to B, so A to B, it is equivalent to A over B. So we had something like that there. We had, let's say, area 1 and area 2. So we can somehow divide them, and as there will just be a ratio there. So now A over B, AB over BD. Just definition of ratio there. Now let us proceed. So as you can see, we have done this for this side. For this side, let's call this side 1. Only this side. Let us go to side 2 now. Let us go to side 2. Again, we're gonna find area of triangle ABC. Area of triangle ABC. This is equivalent to what? Looking at this side, we see that our perpendicular height is H, not K. It's just H because we have exhausted the K there, so we will use H. So using H, we will say our area will be half times what? Times this side, this one, which is our base what? Base AC times our height what? Height H there. Height H there. Okay, so name this what? Name this 3. Now we will find area of this one. Now area of this guy, area of that guy. Remember, area of BCE, the area of BCE, ne? We will use hide H there, because it shares what? Hide H with triangle ABC from side 2. So now we will say, let me find area of triangle BCE. So BCE, it will be half times what? CE times height H. So name this what? Name this 4. So of course we will use definition of ratio here. We will say, let me write it in different color. Area of triangle ABC over what? Over area of triangle BCE. This will be equivalent to half AC times H divided by half CE times H. So this is equivalent to what? So we see that this and this go away, also that one and that one, they go away. We just have what? We just have AC over CE. We just have AC over CE there. So this is of course according to definition of ratio there. So yeah, please appreciate this method on how to prove proportionality theorem. So we are not done yet. We are not done yet. Let us proceed. Now we have another information about triangle BCD and triangle BCE. Check those two triangles, BCE and BCD. They lie between parallel lines. They lie between parallel lines. If you can check from the helper definition, we said that if two triangles lie between two parallel lines, they have equal areas. Okay, they have equal areas. So that's where the helper definition comes in. So we will say, but area of triangle BCD, it is equivalent to area of what? Of triangle BCE. Reason, we see that they have what? Same base, height, and lies between what? Between parallel lines. So that's where the helper definition comes in. All right, so that's where the helper definition comes in. So that means this will be equivalent to what? So we have a right to equate these two. We have a right to equate these two. Therefore we will say we will say AB over BD. AB over BD is equivalent to AC over CE. Why? Because we see that the area of what? The area of BCD. If you can check BCD, this one. The area of BCD, it is equivalent to the area of BCE. So they are equal. So if they're equal and we see that the numerator is a triangle ABC and that one is triangle ABC, so meaning these two are also equal. So AB over BD, it is equivalent to AC over what? CE there as required. I hope this proof is clear. So this is how you prove this theorem, and this is 5 marks to do this. All right, the proportionality theorem. But remember that if we have introduced this as theorem, we need to introduce the corollaries of this theorem. Okay, we have to introduce what? The corollaries of this theorem, meaning the another way of writing AB over BD as AB over BD equivalent to AC over CE as different proportions. Okay, as different proportions. So we will do that in part 2 of the video. Thank you for watching.